review video for the exam on the 22nd. All right, so remember this is from the Prentice Hall book section 2.5 to 7.1. All right, so here are the list of the sections and what they cover. All right, and a note. So this test involves mainly solving two-step equations. All right, so in order to solve a two-step equation, you essentially solve two one-step equations, right? So you will receive a calculator. Therefore, you have to show all of your work for every step, right? So you need to show what you're doing for both sides each step. All right, so general rules. When we solve equations, we are solving for a specific variable. Therefore, we want to get that variable alone, or we want to isolate that variable. All right, so in order to do that, we undo operations. When you are deciding what operation to use, think about how you would get the variable alone. What do you need to undo? For example, given 5x, what's happening there? Well, 5 is being multiplied by x. So to undo that, we divide by 5, right? 5 divided by 5 is 1, so you get just x. All right, so in section 2.5, 3.5, we discussed these problems set up on a seesaw diagram. What was the point of that? Well, when equations are given to us, both sides are equal. When we manipulate the side with a variable in order to isolate the variable, we change the equality of the equation. That is why we have to do the same operation to both sides of the equation, all right? The equation only remains balanced if we do the same operation to both sides. All right, so 2.5 dealt with solving these equations by adding or subtracting. All right, so number one, negative 52, right? That's being subtracted from k. Well, 52 is being subtracted from k. So we add 52 to both sides, and we see that k equals 0. All right, 11, it's negative 44, so 44 is being subtracted. So we add 44 to both sides, and n equals 80. 24, I'm going to simplify first. This goes to negative 40 equals 29 plus m. Well, how do we get m by itself? We subtract that 29 from both sides, and m equals negative 69. All right, 25, t plus negative 2 is really just t minus 2 equals negative 66. All right, so we add 2 to both sides. T equals negative 64. Right, so here it's set up t plus negative 2, so we could subtract negative 2, but we know that that's the same as adding 2, which is what we ended up doing. All right, so 3.5 dealt with the exact same thing, but with decimals. So how do you get m by itself here? Well, you add 17.9 to both sides. When you do that, we get n equals negative 13.15. For number 2, we have two options. Option number 1 is add 8.5 to both sides. We do that because this really simplifies to just h minus 8.5. All right, so adding 8.5 to both sides, we get that h equals 7.9. All right, if you wanted to, you could have undone this adding operation by subtracting negative 8.5, which we know is the same thing as adding 8.5, which is what we did right there. All right, moving on. 2.6 dealt with solving one-step equations by multiplying or dividing. To undo multiplication, we divide. To undo division, we multiply. So x is being divided by 12. Therefore, multiply both sides by 12. This goes to just x, and that right-hand side is 0. All right, number 5, well, we need to multiply both sides by negative 4. When we do that, these go to 1, so it's just y. And we have negative 12 times negative 4 for a positive 48. All right, for number 8, we want to get m alone, so we multiply both sides by negative 55. So that goes to 1, and we get m equals negative 55. Number 9, how do we undo multiplication? With division, divide both sides by 3, or negative 3, and we get that x equals negative 6. Here, how do we undo? Multiplication, again, that's with division. So we divide both sides by -4. On the right-hand side, it's -32 divided by -4 for a +8. All right, well, what do you do? 13, same type of thing. Undo that multiplication with division. So h equals 42 divided by 14, or just 3. All right, moving on to 3, 6, same type of idea, but with decimals. So how do you undo this? Multiply both sides by 4. X equals -2.4 divided by 4, so we already know it's going to be a negative. Comes out to 0.61. Number 2, divide both sides by 1.8. Right? This goes to 1. We get x equals, and it's going to be a positive, 3.2. All right. Now we worked with adding and subtracting fractions in 5.7. Please remember, when you're adding or subtracting fractions, you need common denominators, right? So this one here, really, it's m minus -7, so plus 7/10 equals -1 1/5, which I'm just going to change right now to 6. -6/5 is that improper fraction. All right, so now I have m equals -6/5 minus 7/10 to both sides. All right, so now 6/5 minus 7/10. Coming up here, I need to get the common denominator, so I have -12/10 minus 7/10. All right, -12 minus 7 is a -19, so the answer is -19/10. Or if you want, 1 and -9/10. But please remember that if you change it to that mixed number and you're incorrect, the answer is wrong. So you may as well keep it in an improper if you know that is correct. All right, number 2. -3/4, or 3/4 is being subtracted from k, so I add 3/4 to both sides, and the answer is k equals 2/5 plus 3/4. Well, I need common denominators, and I'm going to pick 20. So that is 8/20 plus 15/20, or k equals 23/20, or 1 3/20. All right, number 6. Subtract 4/5 from both sides to get k equals 1 3/5, or that would be 8/5 minus 4/5. This one, they're already common, so we get k equals 4/5. All right. Number 7, how do we get y by itself? Well, subtract 4/9 from both sides. So y equals 4 minus 4/9. All right, well, how do you represent 4 with a denominator of 9? It's 36/9 minus 4/9, which gives you 32 divided by 9, or 3 5/9. All right, 12. I'm going to rewrite as v minus 4 5/6 equals 2 1/3. All right, so we know that we can also do this keeping it in mixed number format if we're adding. So this looks like v equals 2 1/3 plus 4 5/6. How do you do that? We'll add these two to get 6. So now we have 1/3 plus 5/6. Well, this is really 2/6 plus 5/6 equals 7/6. And now we have to add 6 plus 7/6. Right, well, this is just 1 1/6. So really the whole answer is 7 1/6. Okay, so you could also change those to improper. You'll get the same answer. Sometimes it is easier to add the mixed numbers as they are. All right, be careful if you're doing that when 1 is negative. All right, so take a look at 15. We have z. We are adding 3 2/5 to both sides. All right, so that gives us z equals negative 4 and 1 over 10 plus 3, 2 over 5. All right, so 2 ways to do this. I'm going to show the improper first because I think that way is more straightforward. Z equals negative 41 over 10 plus 17 over 5. So z equals negative 41 over 10 plus 34 over 10 equals negative 7 over 10. All right, or if you go back up here, all right, the whole number is negative 4 and 3. Well, that gives us a negative 1, right? So now we have the fraction part, so negative 1 over 10 and a positive 2 over 5. All right, well, this is really negative 1 over 10 and 4 over 10. So that is a positive 3/10. So now we have a negative 1 plus positive 3/10, or negative 7 over 10. All right, so you get the same answer. Use which way is easier for you, but remember when you're using the mixed number way and one of the numbers is negative, be careful on how you adjust at the end like this. All right, either way, you do get negative 7/10. All right, so 5/8 was all about multiplying fractions. So for example, number 1, it's saying 3/4 is being multiplied by x. Well, how do we get x by itself? Well, you want to divide by 3/4, but what does that mean? Well, it's the same as multiplying by the reciprocal. So what I do is multiply both sides by the reciprocal. This goes to 1, so it's really just x equals, I can multiply straight across or cancel some factors. So I know that 4's come to 4 and 16. And 3's coming to 3 and 9. So when I do all that, I just get x equals 3 over 4. All right, number 3. I want to multiply both sides by the reciprocal, which is 8/3, and you cannot forget the negative, so it's negative 8/3. Doing that gives k equals, well, 2's coming here 1 time, 4 time up here, negative 4 over 3. All right, number 5. So to multiply by the reciprocal, this has to be an improper fraction. So we have 2 times 3 is 6 plus 2, 8 over 3e equals 1 over 18. So now multiply by the reciprocal. All right. We get 1e equals, well, 3 is common here 1 time and 6 here, so that would be 1 over 48. All right, 6, same type of thing. I want to put that in an improper fraction, so we have negative 9 over 7. M equals 6. Multiplying by the reciprocal. We get 1m equals, well, 3 is common here, 2 times here, 3 times, so it's negative 14 over 3. Please make sure you're careful not to lose that negative. All right, finally we get to 7-1, which is all about two-step equations. So main point of the test here is doing what we just did twice. So please remember to undo addition or subtraction first. So to do that, add 5 to both sides, and you get 3x equals 15. Well, now divide both sides by 3, and x equals 5. All right. This one, you subtract 10 from both sides, so you get n over 2 equals negative 3. But then I want to undo that division. Oops, that's not right, sorry. You want to multiply by 2, not the reciprocal. If we would have multiplied by the reciprocal, we'd get n over 4, but we want n by itself. So it's just simply 2. This goes to 1, and we have n equals -6. All right, for number 4, add 9 to both sides. So m over 7 equals -5 plus 9, or positive 4. Now what do? Multiply both sides by 7. It's supposed to be a parenthesis, not a negative sign. All right, so then this goes to m, and we get m equals 4 times 7, or 28. Same type of thing with 5. Add 2 to both sides. 5w equals -10. All right, now we want to divide both sides by 5 to get w by itself. And we get that w equals -10 divided by 5, or -2. All right, a couple more. Number 6, subtract 12 from both sides. 4/8 equals -20. Divide both sides by 4 to get a by itself, and a equals -5. Okay? Example of a good, easy one to check just in your head. So we have a equals -5. -5 times 4 is -20. -20 plus 12 is -8. All right, so we know we're good. We're 100% confident this answer is right. So you can do that for every single problem. Just a reminder. All right, number 7, start with addition or subtraction. Well, if you've been noticing, we're doing the one on the side with the variable first, so we make this into a one-step problem. So b over 3 equals -7 minus 8, or -15. Multiply both sides by 3 now to get b alone, and we get that b equals -45. Finishing up the problems from 7-2 or 7-1. We want x ultimately by itself, so we add 17 to both sides. All right, so that's an add 17. So now we get 4x equals 48. Dividing both sides by 4, we get that x equals 12. Okay, number 2. Or you know what, let's check this one. So we know that 12 times 4 is 48. 48 minus 17 equals 31. All right, so we are good. Number 2. Subtract 3 from both sides, and then we get 12 equals 2m. Divide both sides by 2, and m equals 6. Okay? Number 3. Subtract that 3 from both sides. K over 3 equals 5. How do you get k by itself? Multiply both sides by 3. We get k equals 15. And number 4, we want h by itself, so we subtract 3 from both sides. And we get 4 equals h over 6. How do we solve for h? Multiply both sides by 6, and you get h equals 24. All right, this one here, subtract 18 from both sides, and you get that 9n equals 63. All right, so now we just want to divide both sides by 9. This goes to 1, and you get that 9 equals 7. N equals 7. Okay? Number 6, add this 9 to both sides. Turn it into a one-step problem of 14 equals y over 3. Well, how do you get y by itself? Multiply both sides by 3 for y equals 42. All right, number 9. Add 9 to both sides, and we get v over 8 equals -4. How do you get v by itself? multiply both sides by 8, and we get that v equals negative 32. All right, last one. We want to subtract 25 from both sides to make this go away here. So we have negative 13. F equals negative 14 minus 25. So add them up and keep the sign. So negative 39. Now we want to divide both sides by negative 13 because that goes to 1. And we get F equals negative divided by a negative, so a positive 3. Okay? So please, remember you don't have to show the check step, but it's possible to check every single one of these. You should know for sure if you're turning in problems that are done correctly or incorrectly. All right, so as always, please email me with any questions or concerns. Other than that, good luck.